In recent days, we have done some very interesting and simple scientific experiments from home, but this led us to think about which are the most interesting scientific experiments and especially which are the most important in history. So today, we will tell you these experiments that change the way we look at science. Year 1888, an unknown German physicist called Heinrich Hertz designed this device. He placed this circular antenna 50 meters away from the rest of the device that emits and propagates electromagnetic waves. The electromagnetodynamic era was born. Too much time would pass and it would be necessary to fight against winds and tides for a stubborn theoretical physicist to stop feeding the 1887 experiment as the important one. Technology, following its own path, totally independent, would manage to prove which of the two experiments was right. It was obvious that between 1887 and 1888, it was this one that would give rise to radiotelegraphy. Electromagnetic waves were making their triumphal entry into physics, entry that demonstrated that the electromagnetodynamic waves were and always will be. This is the most exquisite experiment ever made in the history of physics. With it, he proved that space is flooded with oscillating electromagnetic stationary active fields, oscillating fields on which space bases its operation, the electric and magnetic phases. This experiment removed from theoretical physics the paradigm of no propagation medium is necessary for energy. By that, of space is flooded with active oscillating electromagnetic oscillating fields. This process of replacing non-existent force particles by the existence of these active fields. Thanks to this, we have satellite telephony, which is only possible if space is flooded with active oscillating electromagnetic fields that produce and propagate electromagnetic waves. As you know, humans, like many other animals, are unable to breathe in liquid media. We cannot obtain oxygen from the water that quickly enters our lungs. We are not prepared for it as a species. However, one day, there was a strange discovery in a laboratory. A rat accidentally fell into a bucket containing a liquid called Perfluorocarbon. And what was the surprise of the scientists when they saw that the animal could breathe? Science fiction? No. It was a simply amazing reality, an accidental experiment that from a person's point of view was totally amazing. If you don't live into a cave, you probably know about racism and the concept that one group is superior to another. Even 50 years ago, Jan Elliott recognized this and decided to conduct an experiment about it. She named it the Blue Eyes Bone Eyes experiment. When her class of third graders arrived at school one fateful morning, she began dividing them into two categories: children with blue eyes and children with brown and green eyes. The real difference between the two groups is that blue-eyed children have less melanin than brown-eyed children, which affects eye color and skin color. However, she told them, the children, that having more melanin equals being smarter and neater. She quickly started to change the rules, granting more privilege to children with brown eyes. Then she waited to see what would happen next. The experiment had taken on a life of its own. The children began to believe her and act differently. The blue-eyed children felt inferior and the brown-eyed children superior. The brown-eyed children would the playground. The blue-eyed children, embarrassed, went to the corners. Even Elliot, blue-eyed, had brown-eyed girls ganging up on her. Fascinated with the results, Elliot soon reversed roles in the experiment. She discovered that while the blue-eyed boys were the new alphas, they were less cruel than the brown-eyed boys originally were, perhaps because they remembered how they had been discriminated against. Elliot's creative experiment revealed a truth about human nature, that we are naive, and that if we can discriminate against a group to enhance our ego, we will. This carried demonstration to his class of young people, taught them about racism, and made a long-term impact. Personally, the creepiest part about it is that the experiment is still notorious to this day. Now it's time for the extremely bizarre. Scientists at Tufts University have discovered that if you cut off the heads of flatworms, not only will they regrow, but they will also regain their old memories. The scientists demonstrated this by studying the mapping routes used by the worms to navigate a maze before and after their heads were removed, showing that their heads could recover the old routes they had used. But it gets even weirder. If you spread the remains of other worms on the floor for other worms to eat, not only will they eat those remains, but they will also get the memories of the worms they ate and use these memories to help navigate the maze. They sound like some kind of scary monster, unbelievable but scary. Wilhelm Conrad Horntegg, a reputed German scientist in the early 20th century, was conducting experiments with cathode rays when he came across a fact that he did not expect. A cardboard sheet impregnated with PTBA cyanide showed fluorescence. Surprised, he began to report his finding to the scientific community, but the news was met with skepticism. Röntgen did not give up and published an article in the British Medical Journal, attaching one of the first photographs showing a fractured arm. Since then, its use in diagnostics began to be promoted. The invention was awarded the Nobel Prize for Physics in 1901, and its curious name X-ray remains for history, due to the lack of knowledge of its origin. On May 14, 1897, Marconi sent the first wireless communication over the open sea at a distance of 6 km, from the Bristol Channel, England, to Penarth, a town in Wales. The message read, "You're ready." The Scottish physicist James Maxwell in 1864. He proposed the existence of active electromagnetic fields in space. His merit has been to initiate all the technology in telecommunication that began at the end of the 19th century and made Marconi the richest man on the planet. A true Bill Gates of his time, but with the 1909 Nobel Prize in Physics for his contribution for the advancement of humanity. The publication of Newton's Principia stimulated a frantic search for ways to measure the universal gravitational constant and the mass of the Earth. Newton conjectured that a pendulum hung near a mountain would tilt very slightly towards the mountain, affected by the gravitational mass of the mountain. He speculated that if one measured the deflection accurately enough and calculated the mass of the mountain, one could calculate the universal gravitational constant and the mass of the Earth. The problem lies in finding a mountain of sufficiently regular shape to estimate its mass, although Isaac Newton himself did not believe that such a small deviation could be detected and rejected the unlikely experiment. Neville Maskelyne, the astronomer royal, was convinced that the goal was achievable. The Royal Society formed the Committee of Attraction and delegated the astronomer and surveyor Charles Mason to scour the British Isles to find such a mountain. He reported that Sierra Leone, in the central Scottish Highlands, symmetrical and isolated, was exactly the mountain they needed. Unfortunately, he refused to do the actual experiment and died shortly thereafter. Neville Maskelyne took on the job and spent 4 months in 1774 living in a tent in a remote Wenny Valley and leading a team of surveyors to take hundreds of measurements of the mountain. He reasoned that the mass of the mountain could be established from its volume and the average density of the rocks. The deviation of the pendulum, a small angle of 11 seconds of arc, or 11 divided by 3600, equals 0.003 degrees. The size of the mountains and the Earth led him to extrapolate the average density of the Earth as approximately twice that of Sierra Leone. From there, he was able to calculate the mass of the Earth, since the masses of astronomical bodies were known in relative proportions. The mass of the Earth would also allow him to estimate the masses of the other planets, moons and the Sun. A mathematician named Charles Newton was summoned to do all the boring mathematical calculations to estimate the volume of the mountain. The surveyors covered a map with many figures, each making an elevation at some point of the mountain. The data was not easy to use or visualize. Newton connected the points of equal height and created the first contour map. Suddenly, the shape and slope of the mountain became apparent. After 2 years of laboriously dividing the mountain into a set of vertical prisms and calculating the volume of each, the mass of the Earth was approximated at 4.5 billion tons, from which the masses of other major bodies in the solar system could also be estimated. The estimate was not far from the modern figure of 5,972 million tons. The calculation was based on the fundamental assumption that the density of the mountain is constant at 2,500 km by square meters. Newton estimated the density of the Earth at 4,500 km by square meters, very close to Maskelyne's initial assumption and only 20% less than the modern figure. Although Cavendish soon replaced his estimate with a much better one by Cavendish in 1798, more than 200 years later. Cartographers still use Newton's contour lines. European cartographers would adapt them to represent elevation, and they proved to be useful tool for the industrial age approach to mining and railroad and road construction. Thanks for watching me and find me every day on the reels. See you soon!